for the matrices. So the first one is this is 3x, this is 7, a minus 2 and a 4 is equal to 8, 7, 6, 4, which is determinants. So when a determinant is 4 3s are 12x minus 14 is equal to 8 4s are 32. You can't equate the matrices, not equating the matrices. It is determinant, so you have to find the determinant. 8 4s are 32 minus 7 6 are 42. So 12x minus it's plus 14, right? 12x plus 14 is equal to, this is minus 10. So 12x is equal to minus 24. So x is equal to minus 2. Is the answer right? Yeah. So let's go to the next question. Second one, if the determinant of matrix of the order 3 by 3 itself is 4, then determinant of 3a is equal to what? The fact that there is matrices here and a 3 that is located inside of the determinants and next to the matrices, which means the 3 is common for the entire matrices. 3 is common for the entire matrices, and outside of it is a determinant, which means the 3 by 3 from every row you can take a 3 3 3 out. So it's 3 3 9 3 27 into determinant of A. So 27 into 4, 7 4s are 28, 4 2s are 8, 9 10, 108 is the answer. So do you understand that next to matrices A there is a 3, which means entire matrices 3 will be there from every row. Because there is a determinant, I can take it out. So then that's about it. Let's go to third question. Show that an A plus 5, A minus 4, A minus 2 and A plus 3 and A with a 1 1 1 do not lie on a straight line for any value of A. You just have to find the determinant of this. As I told you, the best thing to do is use properties if you can. Row 2 is row 2 minus row 1, and a row 3 is also row 3 minus row 1. If you want, you can also do it without using any properties. It's up to you. The first row remains unchanged. A row 2 is A minus 2 minus A minus 5, so it's minus 7, and A plus 3 minus A plus 4 is just 7, and this becomes 0. This becomes 0. This is A minus 5, A minus A plus 4. So then advantages I can expand along this is 1 into top to bottom minus bottom to top, minus 28 plus 35. So the answer here is 7. I hope my answer is right. Oh, so then I got an answer which is 7, and I have to find the value of A, right? Okay, the thing is to prove that they do not form along a straight line, so the determinant value should not be equal to 0, and it turned out to be 7. Yes, so they do not they are not collinear. That concludes that they are definitely not collinear. And A itself has disappeared. I can't even define what is A, which shows that A can take any value. It can take any value. It doesn't matter because A is anyway disappearing the whole process. So let's go to next question, which is the fourth question. A matrix of 6 minus x 4 3 minus x 1 is a singular matrix, which means the determinant value is equal to 0. So a 6 minus x minus 12 plus x, what is it? If it's a singular matrix, it has to be equal to 0. For what value of x? Okay, 6 minus x 4, 3 minus x 1. So determinant value is equal to 0. That's what singular matrices mean. So determinant should be equal to 0. Let's see if it's equal to 0. So 6 minus x minus 12 plus 4x, right? Yeah. So that's sorted now. So which has if it's equal to 0, because the singular matrices, this x and x will become 3x, this and this will become minus 6, so x is equal to 2. We got answer. So let's go to fifth question. If it's a singular matrices, the determinant of it has to be equal to 0. So 1 2 x 1 1 1 2 1 minus 1 should be equal to 0. Hence find the value of x. So if I can use the property, I would use, because I like more number of zeros to expand, because I am capable of making mistakes. So then I would do column 2 is column 2 minus column 1 and column 3 is column 3 minus column 1. So when I do column 2 is column 2 minus column 1 and column 3 is column 3 minus column 1. Column 1 remains unchanged, column 2 is just 1 0 and this will be 1 minus 2 is minus 1. This will be x minus 1 0 minus 1 minus 1 minus 2 is minus 3. The advantage is I can expand along this. I know this is to be minus, plus and minus. So minus 1 into top to bottom, which is minus 3, minus bottom to top, which is 2x minus 2 within bracket. So then this is equal to 0. So minus 3 minus 2x plus 2 is equal to 0, because this minus 1 goes away. This is minus 1 minus 2x is equal to 0. Minus 1 is equal to 2x, x is equal to minus 1 by 2. Oh, I didn't write the answer. So this is the answer you should have got. Just check out if I made any mistake. That's the way I would do. Okay, so let's go to 6th question. If the value of the third order determinants is 12, so determinant of 3 by 3 matrices is 12. Find the value of the determinant formed by replacing each element by its cofactor. Which means it's like when you replace every element by its cofactor, it's like adj of A, right? So if adj of A is equal to determinant of A whole to the power n minus 1, and this is 3 by 3 matrices, so determinant of A whole to the power 3 minus 1, which is 12 to the power 2, so therefore the answer is 144. So in case they ask twist and turn and ask these questions like this. So then 7th question, if A square is equal to I, then you know A into A is what is I, but you know the property A into A inverse is I, thus you can conclude that A inverse is equal to A. So that's the answer. I didn't write the answers on purpose. A is a symmetric matrix, which you can say, what can you say about A inverse? You know, if A is equal to A transpose, A inverse will also be equal to A transpose the whole inverse. What to say? A inverse the whole transpose is the same as A transpose the whole inverse, or whatever. This is the property. A inverse the whole transpose is A transpose the whole inverse. If A is equal to A transpose, what can you say about A inverse? A inverse will also be A inverse the whole transpose. That's all, right? So as long as you, something to be thought about, okay, this property, I want you to memorize it. That's why I didn't give an answer there. Check the consistency. Consistency means whether you'll be able to solve that equation. The equation is 3 minus 1 minus 2, 0, 2 minus 1, at 3 minus 5 and 0. X, Y, Z is equal to 2 minus 1, 3. Okay, so 3 y minus 2, 0, 2 minus 1, 3 y minus 5, 0. So which means, you know, A into X is equal to B, X is equal to A inverse into B, and to find A inverse is 1 by determinant of A into adj of A, and to be able to find this determinant of A should never be equal to 0. Then only you can find and it will become consistent equation. So determinant of A should not be equal to 0. Just find the determinant of A. So find the determinant of this, 3 minus 1 minus 2, 0, 2 minus 1, 3 minus 5 and 0. Just find the determinant of this. You can just expand along this if you want. So it's 3 into plus 5 into 3 into minus 1 plus 2 plus 5 into minus 3. That's all. So this is 3 minus 5 is 15, so it's minus 10, and so then hence we can say that the equation is consistent. If you are able to get a value for determinant, the equation becomes consistent. So let's go to next question, which is a 10th question. If A and B are the matrix of the order 3, okay, determinant of A is equal to 5, determinant of B is equal to 3, find 3 times AB. First you have to, 3 times AB is nothing but okay, the 3 is, you multiply the matrices A and B. Let me think about it. You multiply the matrices A and B, okay, um, and you have a 3 inside, which means 3 will be common in the multiplication of matrices everywhere. Is it a 3 by 3 matrices? Yeah, of the order 3. So you can take that out. You know it will be 3 3 7 3 is 27 into determinant of AB, because when you multiply matrices A with a B, it will be 3 by 3, result will be 3 by 3, which is equal to 27 determinant of A into determinant of B. So 27 into 5 into 3, so it's 27 into 15, 7 5s are 35, 5 2s are 10, 7 1s are 7, which ones are 2, 5, so 405, that's how you get it. Okay, so first you should understand the matrices AB is a 3 by 3 where there's a 3, so the outside there's a determinant, so from a 3 by 3, from every row you take a 3, it's 27 times determinant of AB. Then the next part of the question is find A into adj of A. Find A into, no, that's a different question. Okay, so sorry. So that's about 11th question. Let me go to 11th question. If determinant of adj of A itself is 64 for a 3 by 3 matrices, determinant of adj of A is determinant of A whole to the power n minus 1. This itself is 64. So determinant of A is therefore plus or minus 8. Okay, so then next is the determinant of A into adj of A. Is determinant of A into determinant of adj of A, or determinant of A whole to the power n also we can say, which is determinant of A whole to the power 3. So 8 to the power 3 is 8 8 is 64, 8 4s are 32, 8 6 are 48, 5 1 2. You can say like that, or you can take determinant of A, which is A, determinant of adj of A with 64, you can multiply and say the answer. There are many ways in which you can answer this. So let's go to, that's all. Oh, it's only so many questions that I gave you. Okay, so I'm done with I hope you all tried those extra sums with the link I had sent from Learn CBSE site, so to just get practice, since you all had enough time over the weekend, at least those who yeah, everybody must have been free. Those who are not going for Fiji classes,